Hello, my C++ students. Today we're moving on to elementary programming, or introduction to programming, or the basics of programming in C++. In this chapter, or in this slideshow, you will learn how to create, compile, and run a program. You should be familiar with that. You will learn how to solve a practical problem, and I'm going to take a particular example. You will learn about the primitive data types. I think you're already aware of that. Int, float, double, char, and a variable, a constant, data types, operators, expressions, input, and output. Now, one of the objectives of programming is for you to be able to write a program to perform a simple calculation. I think you've done that where we've squared a number, we found the square root of a number, we found the area of a rectangle, and you can find the area of a square as well. You are expected to input data from the keyboard. You need to be able to identify name elements in the program. So you need to know the program structure. Variables, that's an important concept. An assignment statement, an assignment expression. You need to use the word or the keyword constant declaration. And I think I mentioned this to you in class where text will not change. That will remain constant for the duration of the program. And what's a directive? Hashtag define. Numeric data types. The operators to write a numeric expression. Remember we did this? Add, subtract, multiply, and in the test you had mod. To convert numbers to a different type. Casting, we haven't started that as yet. Char, naming conventions, what syntax errors, runtime errors, and logic errors. I did that with you, and I think you are able to correct the syntax errors or to debug the program or remove the errors. So let's take an example, a programming example. Let's say, for instance, we want to compute the area of a circle. All right, so here's the program. I'm going to trace through it. You realize that on the top of the program, it's right on the top, include IO stream using namespace standard. I think you're familiar with that. This is where I declare my variables that I'm using. So I taught you the algorithm or the recipe to work a program is input, processing, output. What goes in? What do we need to do? What comes out? Well, they already gave us a clue. They told me that they want us to calculate the area of a circle. So in this case, we are assigning a value of 20 to the radius. I'm specifying, I'm not using an input statement, it's cin, and I'm stating that I'm going to enter in 20. Here's my 20 being entered. I'm assigning the value 20. 20 is assigned the value out here. And area is now computed. If you had to take your calculator, work out what is 20 times 20 multiplied by 3.14159. That's the value of pi. And you should come up to an answer of 1256.636. Right? The area is computed and it is assigned to the variable area. Think of that as a memory location. And the last part of the program is to output the program. And I said I'm going to state the area is cout. Oh, I'm using std endline, right? You know how to take that out as well. Now, reading in from the keyboard, you use the object cin to read input from the keyboard. And here again, computing area, I'm going to run the program. If you want to read multiple input in one statement, you know how to do that as well. Let's talk about this the concept of an identifier. An identifier is a sequence of characters that consists of letters, digits, and underscore. So I told you if you want to have a variable name that is two words like number of pods in a pea. Remember how we did that yesterday? An identifier cannot start with a letter or an underscore. Neither can it start with a digit. An identifier cannot be a reserved word, so I can't use return for that matter. An identifier can be any length. Now, we don't want to have an identifier of 31 characters, right? That's quite a bit. Variables. So here's my variable. Radius is equal to 1.0. So that gives you a hint that's a double. Area is equal to radius times 3.159. Area is a variable. Area is a variable. See out area. I'm displaying that on screen. If I had to compute the second area, I'm going to have to assign it to say radius is equal to 2.0, multiply that out and find the answer. I think I showed you how you can use your program over and over and over again, right? You are looping through it. Declaring variables, we have int x, that's x is declared to be an integer variable, double. Radius is declared to be having an a fraction part. Char, declare a to be a character variable. Assignment statements, x is equal to 1. This assigns 1 to the variable x. Radius is equal to 1.0. I'm assigning 1.0 to radius. A is equal to the character capital A. That's an assignment statement. All right. So you're going to get assignment statements in programming where I'm allocating a value to a variable. Think of it as memory. I am storing a value in a memory location. Or think of it as a container. X is a container, and I'm putting inside of X 1. Declaring and initializing. So if I wanted to save a line or two, I could have said int x is equal to 1 instead of just saying int x, right? So I'm actually doing it in one step, doing 2 for the price of 1. A good idea for programming is always to initialize your variables to 0. So I could have said int x is equal to 0 or int double is equal to 0.0. Named constants. A constant is a data type where the value does not change throughout the running of the program. So the value of pi, for instance, 3.14159, that will not change. Size is equal to 3. So if I have to have age is equal to 26, my age, that will not change for the duration of the program or the duration of the year. Other numeric types you get, short, unsigned integer, int, long, float, double, long, double. We will stick to int, float, double. The float and double types are used to represent numbers with a decimal point. Think of this as your fractions from school. These are called, why are they called floating points? Because of the scientific notation, right? Numeric operators, you get the numeric operators of plus, you've done that. Subtraction, multiplication, we've done that with area, division, and modulus. 20 modulus 3, the remainder, 20 divided by 3 is 6, 6 3s are 18, remainder 2. The result is 2. That came out in your test. Integer division, 5 divided by 2 yields an integer of 2, because I've got 2 remainder 1. 5.0 divided by 2 yields a double value of 2.5. 5 modulus 2 yields 1, the remainder after division. The remainder operator. Remainder is very useful in programming. You know, we tend to use it where we have an even or odd number. That was your test question. By the way, this is why I didn't do the PowerPoint beforehand. I said, let your test be written. All right? So if I look at it, 6 plus 10 is 16. 16 modulus 7 is 16 divided by 7 is 2. 7 times 2 is 14, remainder 2. Displaying time, write a program that obtains hours and minutes from seconds. Again, you can use remainder, modulus. Arithmetic expressions. Oh, this is really complicated. Now, if you have a look at the brackets, I think I mentioned this to you about board mass. Converting to temperatures. This was a program that we've done Celsius to Fahrenheit, Fahrenheit to Celsius. Shorthand assignment operators. Now, plus equals, I could have said I plus equals 8 actually means I is equal to I plus 8. Minus equals, if I had to have F minus equals 8.0, it means F is equal to F minus 8.0. Multiply equals means if I had to use this, I times equals 8, I is equal to I times 8. Increment and decrement. Increase plus a variable. The expression increments a variable by 1 and evaluates to the new value in var after the increment. Var plus like I plus evaluates the original value and increments it by 1. Here's an example. If I had to say int new num is equal to 10 times I plus, it actually means 10 times I is equal to I plus 1. Using increment and decrement operators makes expressions short, but it also makes them complex and difficult to read. Avoid using these operators in expressions that modify multiple variables or use the same variable multiple times. For instance, if I'm going to say int k is equal to plus I, and also try and make your variables a little bit more meaningful. Instead of c, say counter, right? Instead of n, say num or number. Numeric type conversions. Consider the following statement. Short I is equal to 100. Long k is equal to I times, in brackets, 3 plus 4. Double d is equal to I times 3.1 plus k divided by 2. Implicit casting. Double d is equal to 3. Explicit casting. We'll talk about this in the lectures. And write a little program to see what this does. Casting does not change the variable being cast. D is not changed after casting in the following code. So if I had to say double d is equal to 4.5 and then d is not changed. C++ compilers will give a warning when you narrow a type unless you use static cast. Okay, we'll do that in class. Write a program that displays the sales tax with 2 digits after the decimal point. Character data type, you can read that. To read characters from the keyboard, it's C in CH, right? In this case, Char, CH, is my variable, and I'm going to store either letter A, B, C, D, E, F. Example sequence for special characters, \B is backspace, \T is for tab. You'll include this in your cout statement. We've done this. ASCII characters. ASCII, here's all the ASCII characters. You can just Google this and find out what the ASCII values. And what does ASCII mean? American, oops, I shouldn't be telling you this. Here's more character sets. Google the word ASCII, Google ASCII values. Casting between char and numeric types. So if I had to have int I is equal to single quote A, is it the same as int I is equal to int brackets character A? Numeric operators on characters. We're going to do this in class. ASCII for lowercase are consecutive integers starting from the code small letter a to all the way to lowercase letter z. Here's another example for you to work on, computing loan payments. This program lets the user enter the interest rate, the number of years they have to pay, the loan amount, and what is the monthly payment and the total monthly payment. I think some of you have student loans. This will be of interest to you. Here's another problem. The problem lets the user enter the amount in decimal representing dollars and cents. This is an American program, so let's go rands and cents. And a report listing the monetary equivalent in single, let's not say dollars, quarters, and dimes. Let's talk in rands and cents. So here's tracing through the program. Again, remember I spoke about input, processing, and output. What goes into the program, what is it that we need to calculate, and what comes out of the program, right? You can do a screenshot of this and work with this example, right? Here's another problem for you to work on. Displaying the current time. Write a program that displays the current time in GMT in the format hour, minute, second, such as 1:45:19. The time function in the C time header file returns the current time in seconds elapsed since the time 000000 on January 1, 1970. This time is known as the Unix, and you can go on reading about it, right? There's another talking about programming style and documentation. Include appropriate comments. I think you all know by now that your first line should have your student number, second line should be a comment as well, your surname and initials, and your third line should be what the program is all about. How is it that you'll name your variables, right? Is it uppercase, lowercase, small letter, whether you're going to have spaces or a hyphen in between. Indentation, are you going to leave lines in between your program? Are you going to leave spaces? Are you going to tabulate it? And so forth. Right? I hope you benefit from this slideshow, and happy programming. Bye.